from the $100 carbon I've added in bricks.
Okay, I want to go ahead and get started. And today I'm not going to lecture over anything specific. I'm going to take questions. Any questions from Wiley? Any questions from the homework, the written homework? So if you look at the schedule, the written homework, if you have questions on how to find that, pull that up. I want to go over one example, and I don't know if I did a too great a job when I introduced this, so I kind of want to hit it again. And that's when I'm taking limits of a rational expression with a radical in it, or just a rational expression. A p of x over q of x, remember we could always take that highest degree term in the numerator and highest degree term in the denominator. And the quick method, when you have a polynomial over a polynomial, that's great. You're golden. You can always use that. However, when you have a polynomial over a rational expression, if you have a square root in there, or a cubed root, or any of the a root of an expression, sometimes the quick method will lead you around down the wrong path. So let's look at, this is example number 27 from 1.3. So this is one of your homework problems. And we're going to look at the limit as y goes to minus infinity of 2 minus y divided by the square root of 7 plus 6y squared. So some students would say, I'm going to do the quick method, I'm going to pull out my minus y on top, and I'm going to pull out my square root of 6y squared on the bottom, and then factor out the y squared. But I'm going to show you that that's going to lead you down the wrong path. So let's do it the long way first, see what we get our answer, and then we'll try the quick way to see if they match. So if you recall, the method of solving a rational expression was to divide the top and bottom by the highest power of your variable, in this case y. And so the highest power of y in the denominator is the square root of y squared. Square root of y squared is y, right? So I want to divide top and bottom conveniently by a convenient expression of y, so then I can pull y in under the numerator, under the square root of the denominator. So I'm going to pick y to be the absolute value of y, so then I could rewrite that as y squared. I think someone asked why I picked the absolute value of y, and I do that so I can conveniently, when I divide it by the denominator, change the absolute value of y to the square root of y, so I can put that under the radical sign, so I can simplify the radical. Question? This is a matter of multiplying by 1. Your convenient times to, it's not substituting, because you're not substituting anything. I mean, in this case, I could write the absolute value of y with the square root of y squared. I'm going to divide top and bottom by the same thing, but it might not look exactly the same. But it is the same expression. Correct, yes. Anytime you have that radical, you need to divide by the absolute value of your variable on top and bottom, and then conveniently replace that where necessary with the square root of your variable squared. Yeah. So here the variable's in y, but it could be an x, and then I'd just be dealing with x's. So the next thing to keep in mind is the absolute value of y equals y when x goes to infinity, which would make sense if I replace large positive numbers. If I take the absolute value of a large positive number, I get that large positive number. But when the absolute value of y is going to be replaced with minus y, as x is going to minus infinity. Right? The absolute value of a negative large number is a positive large number. So that's why I need that negative to cancel out the negative of the negative.
Would those y's be x, or x's be y's?
Yeah, they would be. I get a little caught up on, yeah. Thank you for that. Occasionally I'll change the variable to t and then think about x going to infinity, but it's y go to infinity, t go to, it's your variable going to infinity. You will, yeah. Okay, so I'm going to, the limit as y goes to minus infinity, I have 2 minus y over the absolute value of y divided by the square root of 7 plus 6y squared divided by the absolute value of y. So I wanted to show this step to show you I'm dividing the top and bottom by the exact same thing. Right? I'm just going to replace, or I'm going to rewrite the absolute value of y as the square root of y squared so I can push that up under the radical and simplify the radical. So if I do this, I have the limit as y goes to minus infinity. I'll go ahead and leave the numerator alone right now. You can, I'm going to write 2 steps, but you can do it in 1. Is there no seats? There you go, you can use the... Yeah, sure. Huh. Maybe sit in the middle some. You can drag this over. Thank you. I hope the fire marshal doesn't come in. Okay. So here I'm going to rewrite this as the square root of 7 plus 6y squared divided by y squared. Does everyone follow that step? I didn't change the expression. I still just divided top and bottom by the same thing. So I get the limit as y goes to minus infinity of 2 minus y divided by... Now I'm going to replace the absolute value of y with minus y because y is going to minus infinity. And then on bottom I have 7 divided by y squared plus 6. Well, I did this in 2 steps. You wouldn't necessarily have to do it in 2 steps. If I replace this with the square root of y squared, it doesn't benefit me in any way. I really want to get rid of this absolute value, so I'm going to replace it with minus y. Yes. Correct. Okay, so now if I simplify my numerator, I have the limit as y goes to minus infinity. I have minus 2 divided by y plus 1 divided by the square root of 7 divided by y squared plus 6. At this point, I can actually plug in my limit as y going to minus infinity. So a constant over something going to infinity goes to 0. So this term goes to 0. A constant as y goes to infinity goes to that constant. The square root of 7 over y squared goes to 0 plus 6. So my answer here is 1 over the square root of 6. Does that make sense?
What's the solution where it's limit as y approaches negative to a 1?
Yeah.
How do you get to negative 2 that first term?
So I have 2 divided by minus y. I just split the denominator. I just split the expression.
So you have 2
So I
separate.
have 2 divided by minus y divided by minus y. Question. When y is going to infinity, if you have a constant over something going to infinity, it's 0. So 0 is 0. It doesn't matter because it's still going to infinity. It's just going there a little faster. But it's still going to go to 0. Okay, question? Yes, exactly. See, I haven't plugged in my limit to this point, so I still have it out front. And then here I'm saying, okay, now I'm going to plug it in. What is this term going to as y goes to infinity? This term is going to 0. This term is going to 1. This term is going to 0. And this term is going to 6.
If that was a positive infinity, a bottom,
The only thing different in this expression, if it was going to positive infinity, is this would be positive y. So that this would be a minus 1.
If you, okay, so when you plug, you had the absolute value of y and then you got to the negative y. Now you did that
Because
that's-
y is going to minus 2.
Okay, thank you.
Okay, so let's look at the quick method. If I take the limit as y goes to minus infinity of 2 minus y divided by the square root of 7 plus 6y squared, and I set that, and I'm going to say, okay, I'm going to look at the end behavior. I have minus y on top, and I have the square root of 6y squared on bottom. I get the limit as y goes to minus infinity of minus 1 over square root of 6. Right? Because the square root of y is y. If the y's cancel. Oh, so, okay, so maybe I should show the step. The limit as y goes to minus infinity of minus y over y square root of 6. It's not the same because y is going to minus infinity. So when you cancel out this y would be going to minus infinity, which would cancel out this negative. So when you cancel that out, you don't have, you're left with this negative, and you don't necessarily know how this is interacting with this negative when you cancel it. Because this y is the absolute value of y. When I take the square root of y squared, that's the absolute value of y. Since y is going to minus infinity, this negative y would be canceling this negative. And you might not see that when you try to do the quick method. Does that make sense? How you're not getting the right answer here? The quick method is not the way to go with anytime you have a radical. If you have two polynomials, you're golden using the quick method. Take the highest power of the variable numerator, the highest power of the variable, and see how it works out. But when you have a radical, you really need to see what's going on.
So when I did this, okay, so in this step, instead of just canceling out the y's, I plugged in the negative infinity. So infinity came out, and then the negative infinity is with the negative outside, which then canceled out.
You can't cancel
Alright, so-
negative infinity with negative infinity.
Well, it went with, so it was, I plugged in negative infinity on top, so then it needed a positive infinity. And then you took the infinity out of the bottom.
Yeah, you can't do that. It's not mathematically correct. Because I can show you an example where infinity over infinity is 5. Right? And that would be the example if I take the limit as x goes to infinity of 5x squared over x squared, that's 5. But the limit as x goes to infinity of 5x cubed over x squared is infinity. And if I were to say, oh, that's 5 infinity cubed over infinity squared, that's still infinity over infinity, right? 5 infinity over infinity, that's 5. But the correct answer is infinity. Because if I simplify this, you can simplify the x terms, but you can't simplify infinity. Does that make sense? Infinity over infinity can be negative infinity, positive infinity, or constant 0. And you have to manipulate it to see how that goes. Technically, it's not mathematically correct to cancel infinities. When we talk about derivatives, eventually we're going to come up with the theorem of indeterminate forms. And an indeterminate form would be infinity over infinity. So you need to manipulate that using derivatives.
That's just the way
The tutor, did they know the answer was positive when they started? So they probably manipulated it in a way that gave them the correct answer. This way is always going to lead you down the right path. This way, you're going to have to really think and take your time. And it would be totally different if y was going to infinity. You really wouldn't have the issue there. So you don't know necessarily when you're going to have an issue and when you're not, unless you're really experienced with things. So you're better off using this method with the absolute value of your variable, replacing that with the square root of your variable squared, manipulating your negatives wherever they may be, and coming to the right conclusion. Question? Mhm. This would be infinity. Yes.
What if that was blocked?
It would be 0.
It would be 0.
Yeah, because if I cancel this, really I cancel this to the limit as x goes to infinity of 5x, right? And if it was flopped, it would be 5 over x. Okay, so let's look at some rules. If I have the limit as x going to infinity of 1 over x, that goes to 0. 1 over something getting larger goes to 0. 1 over something getting larger goes to 0. Any constant. So let's put it as C. A constant over something getting larger goes to 0. If I have the limit as x goes to 0 of 1 over x, this is not going to exist because the limit on the right doesn't equal the limit on the left. So this does not exist, and the reason why it doesn't exist, because if I test the limit on the left, I have 1 over something getting smaller, going to 0, but negative, so that would be minus infinity. And if I look at the limit as x goes to 0 from the right, I have 1 over something going to 0 but positive, which would equal positive infinity. Since the limit on the right doesn't equal the limit on the left, the limit at the point 0 doesn't exist. So 1 over something going to 0, or a constant over something going to 0, goes to infinity. So then we can say plus or minus, depending on if the constant's even plus or minus. So there can be a lot of negatives going around there. So you have to be a little cautious about that. But it doesn't matter here if it's getting larger, positive, or negative. It's still going to go to 0. Increasing in size. So if I plug in the number to the denominator, the whole denominator is getting larger. So that means the whole expression is getting smaller. 1 over 1,000, 1 over 1,000,000, that's smaller. But if I have 1 over a half, 1 over a fifth, 1 over an eighth, those numbers are 2, 5, 8, so those numbers are getting larger. The whole expression is getting larger. When your denominator gets larger and you have a constant on top, the whole expression goes to 0. When your denominator gets smaller and you have a constant on top, your whole expression goes to infinity, or a larger number. Yeah, you're going to simplify it. You're going to take the highest power in the numerator and the denominator. See what you have left. Do you have a power in the numerator? In that case, it's going to go to infinity. Or do you have a remainder in the denominator? So, yes, these two concepts still hold, right? So let's say if I'm looking at the limit as x goes to infinity of, let's say, ax to the m, bx to the n. So I took the highest power of x in my numerator and the highest power of x in the denominator. This is going to equal infinity when m is larger than n. It's going to equal 0 when n is larger than m. And it's going to equal a over b when m equals n. And those should make sense, because if my numerator is higher, it's going to cancel everything in the denominator, and I'm going to have something left in the numerator, and the numerator is going to infinity, the whole thing goes to infinity. If my denominator is higher, when I can simplify it, I have a variable left in my denominator. So I have a constant over something going to infinity, which is 0. And then if they equal each other, they both cancel, and the limit is a over b. Question? In what section? 1.3? Yeah. So let's look at number 19 on 1.3. Number 19. So I have the limit as x goes to infinity. Go ahead and emphasize it's positive infinity. 7 minus 6x to the 5th power divided by x minus 3 plus 3. Sorry, plus 3. Okay. Does anyone think they could just answer the question right now? Kind of eyeing it, you should. What is the answer? Is it infinity or minus infinity? Negative infinity, right? So this is going to act like the limit as x goes to infinity of minus 6x to the 5th over x. So that's going to look like the limit as x goes to infinity of minus 6x to the 4th, which would be minus infinity to the 4th power, which is minus infinity. Right? If it was x going to minus infinity, you'd end up with the same answer. Because minus infinity to the 4th power is positive infinity, and that negative is out front. Question. It wouldn't matter if it was even or odd in this case, because we're going to infinity. And infinity cubed or infinity to the 4th power is just infinity. But if it was going to minus infinity, then that power would play a role. Because a negative infinity cubed is minus infinity, where negative infinity to the 4th power is positive infinity. So that's why sometimes writing that little extra step just kind of confirms if the negative infinity is going to cancel or if it's going to play a role. Here, it's not necessarily too necessary because I know this is going to go to positive infinity because I'm going to positive infinity. So my answer is negative infinity. Question? Number 39. In that same section. So this should look somewhat familiar to one that we talked about earlier. So I have x plus 1 to the x power over x to the x power. Is that the correct one? So recall from college algebra, if I have a to a power divided by b to that same power, I can write that as a over b to the power. I can simplify it that way. Because right now I have infinity over infinity, and I can't deal with that. So it turns out this would be the limit as x goes to infinity of x plus 1 over x to the x power. So if I rewrite this, the limit as x goes to infinity of 1 plus 1 over x to the x power. Does that look familiar? It equals e. The definition of e is this. E is a number. E is a rational expression. And the definition of e is this ratio or this polynomial as x gets really large. So let's look at how this works. Your book talks about how to approximate limits by... Let's see if I can get rid of that glare. The book talks about approximating limits by plugging in points. So let's take... If I plug in 1, if I plug in 1 to this expression, I get out 2. If I plug in 10, I got out 2.59. I plug in 100. If I plug in the numbers getting larger and larger and larger, this is approximately e. So you can see if I take large enough numbers, then the error here becomes very, very small. So e is the definition of e is this relationship with really, really large values of x.
We did in class.
Mm-hmm.
It's 5x cubed minus 2x squared plus 1.
5x cubed minus 2x squared plus 1.
Oh, this is the limit is x to
Okay.
and over 1 minus 3x.
Oh, sorry. 1 minus 3x?
Yeah.
Okay. 1 minus
We
3x.
divided by x,
Mm-hmm.
and I don't understand.
Okay, that's a good point. You bring that up. Okay, I was trying to show you how the error of the quick method or the long method. So, the quick method, I would take the highest power of x, right, in the numerator, and the highest power of x in the denominator.
And you say you recommend that
Yeah. Yeah. So the approach to this would be the limit as x goes to infinity of 5x cubed over minus 3x, right? Which would work out to be minus 5 over 3x squared, which would be minus infinity. I was trying to show in the notes how you can get the same thing by taking the limit as x goes to infinity of 5x cubed minus 2x squared plus 1 divided by x divided by 1 minus 3x over x. So you see the limit as x goes to infinity, I have 5x squared minus 2x plus 1 over x divided by 1 over x minus 3. Does everyone follow to this point? And so now, if I plug infinity, I have infinity, because this is the highest term, so the whole polynomial here is going to act like this highest term. That's going to infinity. Divided by minus 3, which would give me minus infinity. But I wanted to point out, to be very careful, you don't try to divide by the highest power of x in the numerator. Because if you do that, you end up with the answer of being 5. Obviously, the limit is not 5, it's minus infinity. So if you took the limit as x went to infinity, 5x cubed minus 2x squared plus 1 over x cubed divided by 1 minus 3x over x cubed. And I try to simplify this, I'd have 5 minus 2 over x plus 1 over x cubed divided by 1 over x cubed minus 3 over x squared. So I'd have 5 minus 0 plus 0 over 0. So I have a constant over something, and this is going to 0, right? I have a constant over something going to 0, so I would think that would be infinity, right? My constant here is positive, but my answer is minus infinity. So you have an error there. So you have to only divide by the highest power of x in the denominator. You try to do it by the numerator and try to simplify how that's going to work, you're going to be off by a possible negative or depending on the setup of the problem.
It doesn't matter if it's not like a common power of x.
No, it doesn't. You only look at the highest power of x in the denominator.
That's what the stopping means. It's like, I can't do that. This is not just an x term.
Yeah, it doesn't matter. You take the x term, and it turns out that this is going to infinity, this is going to minus 3, so your answer is minus infinity. But here you lose that minus, it's still going to infinity, right? A constant over something going to 0 goes to infinity, but you don't know if it's plus or minus. So you lose that by trying to do, because if you divide by too high of a power in the denominator. Because if you divide by the highest power in the numerator, then your denominator is going to go with simply 0. And you're at a loss of plus or minus. Question?
So in the numerator, the 5 times infinity squared minus infinity, that doesn't matter, just acts like the first.
Exactly. Yeah. Because what this is saying is x is getting large enough that this x squared is going to overpower this x. So it doesn't matter that you're subtracting it or if you're adding it. It would matter. You just look at the highest term
So the first method is perfect.
with polynomials. If you have a polynomial divided by a polynomial, just be very careful with your coefficients in front of the highest degree term. When you have a rational expression, that's where you need to be careful. The quick method can lead you around, you have to like make this trick up to get it to force it out to be the positive or negative. Generally, you'll get the number, or you'll get positive, but you won't always get positive or negative. Any other questions on written homework or online Wiley homework? One question I had in an email that I wanted to kind of reiterate. When you put in do not exist, you have to use capital do not exist. It won't accept lowercase do not exist. So if you found that out the hard way, hopefully
It wasn't on your fifth try, right?
Hopefully it wasn't on your fifth try. I think one student had tried various different things and it didn't accept the do not exist. I give them their points back. So if it was on your fifth try, let me know. I can look that up and give you your points back. But these are just some of the things you learn as you go about it. You'll be using Wiley in Calc 2 and Calc 3 if you take Calc 2 and Calc 3. So get used to it. It's your best friend. Any other? Wiley has some decent resources. I'll just kind of, if you haven't explored Wiley too much. Okay, so if you, in your student view, say you have this read, study, practice. So if I go into chapter 1, you have additional material which really doesn't come up. These are web appendix of more chapters that they couldn't print to the book, so they still give you access to them. Interactive applets, sometimes these just kind of come nice when you want to play around with a figure in the book and how it works. So it takes Java, so if you don't have Java, which I don't, yeah, this computer does. So you can kind of see the tangent line. You can move this point around to kind of see how this tangent line works. Here I'm going to have a positive slope. Here I'm going to have a negative slope. Sometimes those come in handy. Student solution guide. So you used to have to buy this with your textbook. This is the student solution guide. Study guide, sorry. The solution guide's also there. Solution manual. So this is what you would have in the back of the book. If you had a physical copy of the book and you flip to the back, this is what it would look like. But the student study guide comes in handy, and it's on chapter 1, and it gives a summary of each section, and it gives, basic ideas and concepts. But towards the end, it gives multiple questions with multiple choices, and it also gives you the answers to these multiple choices at the end. So if you kind of want to start preparing for the first exam, you can look at this and say, okay, I'm going to study for 1.5, and I'm going to look, okay, multiple choice, but your problems won't be multiple choice. So, but you get that feedback of, yes, I got that one right. I could pull that out on my own on an exam. So, last semester students that started using this later in the semester wish they knew about it from day 1. So, all the chapters has student solution guide. Keep in mind, though, we didn't do chapter 1.4. So if you try to do the problems in 1.4, it's going to look pretty foreign. Question?
Yeah, I just remembered I had a question on, what was the written homework? It was number 5H. The limit is x goes to positive infinity. My answer that I ended up getting was 18 over 0, which I know does not exist.
It's 18 over something going to
Going
0.
0.
What's a constant over something going to 0?
Oh,
Right?
okay, yes.
What is that? 1.2?
I did it wrong. So maybe we can do that.
Okay, let's look at this one. What section is it in again?
It is 1.3.
1.3.
Number 5H.
Okay, so let's look at 1.3, number 5H. So we're given the limit as x goes to infinity of f of x, g of x, and h of x. For g, if I took the limit on top, I would go to 4, and on bottom I would go to infinity. 4 over something going to infinity goes to 0. On h, f of x goes to 3, so on top I'm going to 18. And on bottom I'm going to something that's going to 0. something that's going to zero, but not going to zero, you can test the right side limit and the left side limit. They're not going to equal each other, so the limit's not going to exist here. So let's write this one. Question? Huh?
I want to see
15 on the same problem. So I'll do 15 after this one since it's pretty straightforward. Okay. I have, this is 5h. I'm taking the limit as x goes to infinity of 6 f of x divided by 5 f of x plus 3 g of x. Okay. So here I have 18 over 5 times 3 plus 3 times minus 5. So this is going to 0, right? But I'm not on the right or the left, it's just going to 0. So I need to test, okay, is it going to 0 positive or going to 0 negative?
Yes, you got to check both.
So you have to check both sides, the limit on the right and the limit on the left. So if I test the limit as x approaches, let's see, well in infinity, if it's going to 3, see if there's no right and left to check, and you have something over something going to 0, that's always not going to exist. And I think number 15 will clarify why this is. So let's look at 15. Well, we need to check the limit on the right and the left, but with infinity, there's no limit on the right or the left. So 18 over something going to 0, it could be going to 0 from the right or going to 0 from the left. We don't know that, so it's not going to exist. Because I could have the graph of this. I could have a function as it's going to infinity. If I think of f of x, so this is our f of x function, as it's going to infinity, this is the value 3. It could be above 3, so it's always larger than 3, or it could be below 3, where it's always less than 3. So that would be how this would plug in here. Does that make sense? Because the horizontal asymptote means that it never equals 3. So if you look at the given information here, the limit as x approaches infinity of the function goes to 3. But the value of the function never outputs 3. The larger and larger you get to infinity, the closer and closer you get to 3, but you're always above 3 or always below 3. That's the whole definition of horizontal asymptote, right? And it doesn't tell you that. So in this example, the limit would not exist. But in this example, you would have a constant over something going to infinity that goes to 0. A constant over something going to 0, if it's on the right or the left, could be positive or negative infinity, but at that point, it's not going to exist unless it's both equaling affinity or both equaling minus infinity. So let's look at number 18 and then you guys, or 15, and then you guys can take your quiz. So I have the limit as y goes to minus infinity of 3 over y plus 4. So I have a constant over something that's going to minus infinity. What's a constant over something going to minus infinity? 0. Constant over something going to positive infinity is also 0.